I'm super excited to be talking about this topic. This is a topic that I wanted to talk about for a long time, but it's a tricky topic to approach properly because we need to cover this topic from many different angles simultaneously, and there are a lot of traps of the mind that we can fall into very easily. So we've had to build up to it. This talk is going to be about quantum mechanics and non-duality. I'm not going to get into super technical detail about what quantum mechanics is, although I will cover the basics. What I'm interested in, though, more is the big picture. And I'm interested in the ramifications of quantum mechanics. What are the metaphysical and epistemological ramifications of quantum mechanics? And what can quantum mechanics say about spirituality or non-duality? Is there something worthwhile there to be gleaned from this science? And let me address this concern right off the bat that what I'm going to be doing is just doing some typical New Age justifications of spirituality or religion. That's not what I'm going to be doing. I'm actually going to be quoting to you from very serious scientists, not quacks, not fringe people, not New Age people. I'm going to be mostly quoting to you from the fathers of quantum mechanics themselves, the big guys, Schrödinger and Einstein and Richard Feynman and Arthur Eddington and Niels Bohr and people like that. So these are the guys who actually invented quantum mechanics. And they were not just regular scientists, they were real pioneers. And we'll get into that as we keep going. Quantum mechanics is very easily misused by New Age people or religious people who want to use it as justification for the dogmas that they already hold. That is not what I'm interested in doing here. What I'm interested in is in showing you some very deep connections which exist between quantum mechanics and non-duality and spirituality, but in a way that probably you haven't heard before, and this will blow your mind if you stick with me through the end. At some points, this talk will get a little bit technical, and I'm going to be quoting to you a lot from these various scientists and physicists precisely because I don't want these ideas coming just purely from me. I want you to understand that these fathers of quantum mechanics, that they really understood the deep metaphysical and epistemological ramifications of their discoveries in a way that many modern scientists and modern physicists do not, because they subscribe to the materialist paradigm. What's not taught to us in school, and what almost nobody really knows in mainstream culture, is that in the 1920s, there was a silent metaphysical and epistemological revolution that happened in Western intellectual tradition. It was utterly ground shaking. But the problem is that these ideas can become so abstract and so esoteric that they don't easily permeate into popular culture. And so the general population still does not know of the metaphysical and epistemological revolution that happened in the 1920s. Most popular cultural conceptions of science and also of what reality is hundreds of years out of date. And this is a shocking fact to discover. And the reason it is because this stuff is rather complicated. It can be sometimes technical, and it can be sometimes difficult to see what are the practical implications of this stuff. So this is not taught to you in school, and it's not really even taught to you in university. For example, if you're watching me for the first time, you might think that I'm some New Ager, or that I'm some religious person, or I'm trying to justify my Christian beliefs or whatever, or my Buddhist beliefs. Not at all. I was an atheist my whole life. I went into hardcore philosophy, epistemology in university. I studied philosophy of science. I studied logic. And I was an engineering major as well. So I studied hardcore physics and calculus for 2 years of my engineering degree. It was just nonstop physics classes and calculus classes. So like really hardcore stuff. And I was a pretty good student, so I got A's in most of my classes. And I understood the material, and I was pretty good at physics. And despite that, even though I took more physics classes than most people can dream of, they still didn't teach me this stuff in university. And even though I took a lot of philosophy classes, I only just scratched the surface of the implications of quantum mechanics. It required lots more research later after that on my own initiative to really understand this stuff. They just don't teach this to us in university because it doesn't have a lot of practical implications, or so it seems. Actually, the implications are enormous. They are enormous and they are extremely practical. But of course, this doesn't resonate within academia. The problem, though, is even worse than this. The metaphysical implications of quantum mechanics are so poorly understood that even the hardest scientists that exist today and the most reputable academics who have Nobel Prizes and who are PhDs at Caltech and MIT and who actually work within the field of quantum mechanics and are doing cutting-edge research, they themselves still do not grasp the enormity and the profundity of the metaphysical and epistemic implications that were discovered in the 1920s by some of these fathers of quantum mechanics. They still don't understand, because there's a big difference between being a good scientist and publishing research papers and doing laboratory experiments. That's one thing. You can be really good at that. But then to understand the significance and the implications of your work and what that means for the human psyche and human consciousness and how to live one's life and what that means for metaphysics and epistemology and philosophy, that's a separate domain. You can be good at one and terrible in the other. And one of the things I'm claiming is that many modern hard physicists and scientists are really bad at this second aspect of the domain, which is why this conversation is so necessary. This is something, this conversation we're having right now is not just something as an introductory course that you can give in a university to freshmen. This is something you can give to PhD students. This is something you can give to Nobel Prize winning physicists like Stephen Hawking. Well, I don't know. Did Stephen Hawking win a Nobel Prize? I don't even know. But, take someone like Stephen Hawking. You can talk to him, have this conversation with him, and he will learn something from this if he's open-minded. Now, of course, the trick is once you're at that class of intellectual or academic as Stephen Hawking, well, are you really going to be inclined to be very open-minded and have these conversations? Maybe not. There's an important distinction that we need to make to really understand what's going on within science, to make sense of science. This is a three-part distinction, a triple distinction. So first, well, before we can get into the first part, when we say the word science gets thrown around a lot as though people understand what science is. But science is a very, very tricky thing. And in fact, I'm going to have an episode in the future that's just going to talk about what science is. And we're going to get into a little bit of that here, but I'll cover it more there. But so this word science, it's so tricky. It's so tricky. It's so self-deceptive. People use it in different ways. First of all, there's popular science, the popular layman conception of what science is, which is extremely sloppy. It's just this idea that, science is the way that we know things and the way that we engineer things. And we just listen to the scientists, and the scientists just deliver truth to us, and whatever the scientists say is just true. And science, in this sense, is just the polar opposite of religion. And so either you're religious or you're scientific. And if you're scientific, that means you're aligned with the truth. And if you're religious, that means you're aligned with superstition and dogma and biblical references and stuff like that. And you believe in various mythologies, which is the polar opposite of science. And everybody knows that religious beliefs are not true and have nothing to do with reality, whereas science is the thing that actually tracks reality. This is a very gross characterization of what science is. Science does not actually work this way. This is the myth of science. This is an idealized version of science. This is not how science actually works. Then there is the modern technical hard version of science. So if you are actually a scientist, a physicist, a chemist, a biologist, you work in a university setting, or maybe you've studied science a little bit more in depth, such that you actually study the philosophy of science, then you understand that science is actually a lot more tricky and technical than most people assume, and that it's not so easy to discover what's true from what's false. And you've studied the history of science, and you realize that actually, throughout history, many scientists were religious, and they were superstitious, and they were spiritual, and also to distinguish between whether a theory is actually true or not is not simple. And that science is not just raw truth. Science is not just the doing of experiments. Science is also the conceptualizing models and theories and frameworks that are put forth, which need to be tested against reality. And that process of testing these theories against reality, that's challenging, that's tricky, that's a non-trivial process. And it can be highly error-prone. And it's very easy to delude yourself in that process. And that science is always in a process of revising itself. And that in fact, at any given point, many aspects of modern science could be flawed or wrong or incomplete, and they will be radically changed in the future by scientific revolutions, by a shift in paradigm. So that would be a more nuanced understanding of what science is. And then there is even a third layer. And the third layer is visionary science. This is where science sort of comes at the intersection with philosophy and with metaphysics and epistemology. And this is where you go beyond just doing laboratory work. You know, the modern technical scientist in an academic institution, he writes research papers, he does laboratory work. He's not usually a visionary scientist. He's not a genius. He's not a philosopher. Whereas the fathers of quantum mechanics, like Albert Einstein and Niels Bohr and Schrödinger and Heisenberg and others like that, which we'll be discussing, they were not just laboratory technicians. These were visionary theoreticians and philosophers first and foremost, and scientists really secondarily, which is in fact why they were able to make these radical breakthroughs and created the quantum mechanics revolution. And these guys had a very different understanding of science than even just modern technical scientists that you find in many universities. And these guys were just not materialists the way that modern technical scientists in universities are. Because you see, what modern science has devolved into is a pragmatic exercise of doing laboratory work, finding out certain correlations between phenomenon in the world, how something works, and then selling that technology or that information to other companies, starting businesses, starting pharmaceutical companies or technology companies, making money off of it, or just writing research papers and building your status and career as a scientist for doing this sort of stuff, getting Nobel Prizes, that sort of stuff. All of that can be done in a sort of mindless, unconscious way without grounding it in the human experience and without understanding the deep philosophical ramifications of what you're really doing. You see, in the same way that you can build a nuclear bomb using scientific theory, but Are you thinking through what you're doing and why you're doing it when you're designing this nuclear weapon? Are you seeing that this thing will be used as a weapon of war? You see, because modern technical scientists who are materialists, they don't care about that stuff. For them, it's a purely pragmatic exercise, mostly. I mean, I'm not saying they don't have heart. I'm not saying they don't care if people die, but mostly it's just a sort of mindless process of, can we make a discovery? Can we make a technology out of it? Whereas if you're a visionary conscious scientist, you will think through the consequences very carefully. And it's not just going to be about what kind of technology can I create. You're going to have to connect that more holistically with questions about, how is this going to impact humanity? Is this something that's ethical or moral? Is this something that is going to increase the consciousness of the world or decrease the consciousness of the world? What are we getting ourselves into? And what are the philosophical implications of all this stuff? See? So make this distinction in your mind between these different levels at which we can talk about science. So when I say science, what do I mean by that word? Am I just talking about popular science? Is this some idealized myth? Am I talking about this technical science that's done in universities? Or am I talking about this very deep, genius level philosophical science, which, is very rarely done these days? It's very rare to find people who are at this level. That's sort of a quaint notion these days, because our society is actually becoming more materialistic in a sense. And we'll get into that. Now, before we get into the really heavy stuff, you might be wondering, well, Leo, why are you qualified to talk about quantum mechanics? Who do you think you are? How arrogant of you. Where's your PhD? Where's your Nobel Prize? Where are your books? If you are not a professor, then why should I listen to you over a quantum theorist who's credentialed? How can you actually honestly believe that you know more than them? Well, a couple of points to address here. It's true, I don't have a PhD and I'm not a professor. And in fact, I haven't read that many books about quantum mechanics. I haven't studied the technical details in that much depth. I haven't really looked into the mathematics of it. But my points here will not be technical or mathematical. They will be metaphysical. They will be philosophical. Now you could say, oh, Leo, but if you don't do the mathematics, then really, what do you understand about quantum mechanics? Well, as a counter to that point, I would say that if that's the level of rigor and standard that you're going to apply here, then we can hardly talk about anything, because most of the time when we talk about anything, we are not technical experts in the thing that we're talking about. And yet, nevertheless, we feel like we can talk about it at a high level and get a big picture understanding of what it is. We can talk about cars, and we can talk about the philosophical implications of cars and what they mean for our life without actually being car mechanics or engineers. You see, because that's irrelevant. Those details are largely irrelevant. We can trust on reliable experts. So by no means am I saying that these academics and these PhDs are useless people who don't provide us with valuable information. No, they do good technical lab research, which we need. And then we need to be able to rely and trust on them to do accurate lab research and to share their conclusions with us so that then we can work with those conclusions. So that's what we're doing here. Nothing I say is going to hinge upon the mathematics of quantum mechanics. And I'm not going to bore you with all those details. This is actually going to be a very juicy and interesting topic. This is not going to be a dry topic at all. We are going to explain the very origin and substance of existence in this topic conclusively, at least as much as possible, as it is possible, using language and using concepts. Another point I'll make about this qualification issue is that I have studied epistemology and philosophy of science very seriously since my teenage years. This is something that's been a deep passion of mine. And in fact, my deepest passion is not personal development. And it's not even enlightenment. My deepest passion is really philosophy of science and epistemology, understanding what is knowledge and how does it work and what are the limitations of knowledge. That has driven me my entire life. And that's ultimately what deeply grounds my personal development work and all my consciousness work and all the enlightenment stuff that I do and all that. So I've read quite a lot of different philosophers on this topic. I've I've read a lot of scientists. I've thought about this stuff deeply. So my deepest qualification is not a certificate or a PhD. It's simply that I've thought about this stuff. I've been passionate about it and I've cared about it. And that's really the only qualification you need to understand a thing. You need to care about understanding it, and you need to contemplate it. And that's it. And everything else is nice, but it doesn't guarantee you accuracy or truth or really deep understanding. Only contemplation does. Another point about qualifications is that I am going to be citing very serious scientists to you here. I'm not going to be citing New Age quacks and crackpots and speculative theorists who have crazy ideas and crazy interpretations. No, I'm going to be citing to you the guys who actually invented quantum mechanics. I'm going to be citing to you modern scientists who are from Caltech, from MIT, the most reputable people. So I'm going to be using their words to make my points. Now, of course, I'm not just going to confine myself to their ideas because their ideas are limited. We're going to take it to the next level. So I am going to embellish and elaborate a little bit, and I'll point out where I'm doing that. And the final point I'll make about qualifications is that even more important than having technical mathematical knowledge of quantum mechanics is actually experiencing profound states of consciousness, non-ordinary states of consciousness. And that's something that I have quite a bit of experience with at this point. I've experienced profound states of consciousness, which, not to brag, I'm not bragging here, I'm just saying this as a fact. I've experienced these states of consciousness which almost no human being has ever experienced on this planet. And the depth of these states of consciousness is extraordinary and mind-blowing. And from these states of consciousness, one can see the very profound interconnections between quantum mechanics, for example, and spirituality or non-duality or epistemology or metaphysics. So that is something that I wish more scientists had, because then they would be talking the way that I'm talking here. But again, we'll get into that a little bit later. So what is my key argument or thesis for this episode? It's as follows. There's several points to it. Firstly, my thesis is that quantum mechanics corroborates non-duality. What quantum mechanics basically points to is the fact that reality is a non-dual singularity and that all distinctions are untenable and must ultimately collapse. Secondly, my thesis is that quantum mechanics conclusively debunks materialism and the notion of there being an objective reality or physicality. These notions have been killed since the 1920s. Reality is not material, it is not objective, and it is not a linear, rational, clockwork machine. Thirdly, my thesis is that paradox is inherent to reality. There cannot be reality without paradox. Paradox is not a mistake. It is not a bug. It is a feature. It is the thing that makes reality occur. Reality is a strange loop. And that when we get to the root bottom of the substance of what reality is, to the bottommost levels, what we must discover is that it will cycle back around and involve ourselves and itself in a paradoxical strange loop. If you're not familiar with the concept of strange loops, go watch my very deep and profound episode about reality is a strange loop, where I talk about that in great length. That episode is going to be very important to understand what I'm going to be talking about here, because the deep structure of reality is a strange loop. Fourthly, my thesis is that the consequences of quantum mechanics are too radical. So radical that the human mind cannot cope with them. They cannot be believed and they cannot be logically understood. The only way to really understand the full consequences of quantum mechanics is to transcend the human mind and to go to levels of consciousness which are transcendent levels of consciousness, which most human beings have never experienced and don't even know are possible. And that the consequences of this are so radical that it will literally destroy reality itself and it will end your very life. That's how radical the consequences are. This is not a mere intellectual exercise in philosophy. This is not merely a system of belief or some new age religion that I'm talking about, nor is this even science that I'm talking about, where you can write a textbook about this stuff. What I'm talking about is to embody these consequences is such a radical thing, and the only way to understand these consequences is to embody them, that it will literally kill you. That's a rather bold claim. And that takes some explaining. We'll get into that. And fifthly, my thesis is that people who say that quantum mechanics has nothing to do with non-duality or spirituality, and there's a whole group of people that say that, including scientists and philosophers and even enlightened people, that they are wrong. And I will show you how that is the case. So let's begin. First, we have to understand the classical model, which is the alternative to the quantum mechanical model of reality. The classical model is what I call the materialist paradigm. It is the de facto way that you think reality works as you're born. And part of it is because it's imprinted to you by culture, and part of it is simply because I think that's how the human mind is actually wired. It's wired for this classical, simple, materialist model of how reality works. What does this model really say? This model says that there is a physical reality. We see it, we interact with it, it's an objective thing. I was born into this reality. I exist as a physical body within this reality. This physical body, if it gets killed or harmed sufficiently, it will die, and that will be my exit from this reality. But the reality itself will still be there. It was there before I was born, and it will be there after I die. This reality, what is it made of? It's made of ever smaller building blocks. Particles. Particles made out of more particles, made out of more particles. Cells made out of molecules, made out of atoms, made out of electrons and protons and quarks and neutrons and maybe strings at the very lowest level. And that ultimately there is a substance to reality. There is an objective way that reality is. And of course, we can't deny the most obvious thing of all, which is that reality is. That's the classical materialist model. There are a lot of very subtle implications, metaphysical implications that come with this model. Most people don't realize that it's a model at all, or that it's a metaphysics at all. People just hold it as reality. It's like, well, how could it be any other way? What's the alternative? Of course it's like that. What's even the point of discussing this stuff? That's how most people hold it, including many serious scientists. The classical model comes about from, well, really it stretches back thousands of years, all the way to the ancient Greeks, and probably even way before that. Because like I said, it's probably hardwired into our human psyche. But there were a couple of key thinkers that really solidify this model in Western intellectual tradition. And they were Democritus, Aristotle, Euclid, Descartes, Newton, and Laplace, amongst many, many others. But these were sort of the big guys who shaped this paradigm. Most people aren't aware of this. Most people aren't aware that when they're born, they're picking up these ideas which came from these people and have really constructed this sort of conceptual cultural framework. See, most people don't understand that culture and science are inextricably linked. Science is a part of culture. All your scientific beliefs are a part of culture. You understand this? It's very twisted. Science is not just someone sitting in a laboratory doing experiments. It is that, but it's much, much more than that. It's very cultural as well. So this classical model, Democritus, he was a Greek who basically came up with the idea that the world is made out of atoms. And that idea has still stuck around even to this day. Most people today believe the world is made out of atoms, right? That's what the average person on the street believes if you ask them. Of course, quantum mechanics has disproven this long ago, but we'll get into that. Then there's Aristotle. Aristotle came up with all these rational categories for dividing the world and reality, and science is basically still stuck with that idea. There's Euclid, who came up with just geometry, the postulates of geometry, and he came up with Euclidean geometry. And for a long time, for thousands of years, it was thought that Euclidean geometry is the only kind of geometry, until later we discovered non-Euclidean geometry, which then led to discoveries of Albert Einstein, and we'll get into that. And most people today still think that reality is Euclidean, that there's no other kind of geometry but Euclidean geometry. Then, of course, there was Descartes, and Descartes was huge. Descartes really enshrined the idea of dualism. The idea that there's matter and then there's spirit, or there's mind, and that these are two separate entities, and that what I am, I'm a physical body, but I'm also a mind inside the physical body. And there's the physical external world, but then there's the subtle internal world. And that duality, that is a huge, huge component of every human being's operating system and how they interact with life as a whole, right? You actually believe that there's an external physical world, and then there's an internal world of emotions and colors and sights and sounds and phenomenon. And that this private inner world is separate from the external world. And it doesn't make sense how anything else could be true but that. Then there's Newton and Laplace. Newton, of course, came up with calculus and Newtonian mechanics. And that was good for describing how physics works in the normal, everyday sense of the of the world. But then Einstein came along, and ultimately Newtonian mechanics, we know, is actually inaccurate. It's an approximation. It's not really true. And so from Newton and Laplace, this idea came about that the world is this clockwork universe. God, because Newton was a believing man, Newton said God sort of created this clockwork universe and set it to run, and now it just runs by itself like this elaborate, perfect clock. Now, what modern scientists do is they say, well, we don't need God. Screw God. We throw God out of the picture, so we just have this clockwork universe. And it works perfectly. It's mechanical. It's all causal. It's all rational. You can figure all of it out, and it just works perfectly. But of course, this was disproven by quantum mechanics. So that was the classical model. This classical model can be called realist, materialist, atomist, rationalist, and objectivist. That's the metaphysics of the classical model, and this metaphysics has so thoroughly permeated and infected Western culture that it has become reality. The very word reality means that. And it's not clear what else it could possibly mean. But if you've actually studied modern science, then you've been shocked to learn that with the discoveries of quantum mechanics and general relativity, Einstein's work, and also chaos theory, it has been shown that reality is actually non-linear, non-rational, non-Euclidean, non-Cartesian, non-Aristotelian, acausal, non-physical, and highly relative. Now, what all of that means, we'll get into in a little bit. But basically what it means is that reality is not a clockwork machine. when you really investigate this idea that reality is a clockwork, it appears like a clockwork when you look at it superficially, but when you really bore down to the very bottom of it, you discover this notion of a clockwork, it doesn't work, it collapses, which is exactly what quantum mechanics reveals. So then what is reality if it's not a clockwork? As I've said in my Understanding Absolute Infinity episode, and I explained it in a lot of depth there with a 2-part series, quite a long one, but very worthwhile to watch, is that reality is an infinite, intelligent, conscious singularity. Reality is not a physical thing. It is not a physical clock. It is mind stuff. It is an infinite hallucination or an infinite dream. And within this dream, you can experience physicality as a limitation of the larger set of possibilities. You can experience physicality. You can experience a condensed form of consciousness where you are a self or an ego or a body, or where you're doing science, or where there is a physical objective world. But really, this is all relative and subjective. And itself, this dream has no substance and it doesn't really exist. That's pretty twisted. That's a pretty bold claim to make. How can I make such a bold claim? Well, the only way you can discover this for sure for yourself is through direct consciousness of non-duality, which is called otherwise enlightenment or awakening. That's the only true way that you can really get it. And that requires going beyond ordinary human levels of consciousness. It is possible to do. Many people have done it, but relatively few people have done it compared to the billions of people alive on this planet. And we are still at this point in human evolution and human history where this stuff is not gone mainstream yet. And it's still very difficult for people to understand this stuff precisely because they're locked into the dogma of the materialist paradigm and they don't see that they're locked into it. But short of having these direct experiences, which you can have, and I've talked about many times in the past how you can have them. There are many techniques you can use. I've shared all the techniques with you. So I'm not hiding anything. You can go and do it. There are many shortcuts you can use, many different technologies and methods. So this is not just, religion here. But, short of having these direct experiences, what you can do is you can also understand how modern science fits in with that and how it points to it. See? In the same way that, they started discovering planets that exist outside our solar system in the last 10, 20 years. They've discovered hundreds now of these. They're called xenoplanets, planets that you can't really see visually because they're too far away, but how did scientists discover them? Well, they couldn't see them through a telescope because there's not enough light entering the telescope to actually see these planets. So what did they do? Well, they made an inference. And so what they do is they track the actual gravitational pull that the planet has on the sun, which not our sun, but a star far, far away, a star. You see the gravitational perturbation of the orbit of that planet around this sun, and then you can see this star, it wobbles like this. You can see the wobble. It's a tiny wobble. You can't see it with your eyes, but you can measure it with precise instruments. And so through this sort of wobbling effect, they can infer that, there must be a planet there. And they can even calculate how many planets and how big the planet is based on the wobble. You see? So in precisely the same way, we can use the discoveries of quantum mechanics to intuit or infer that there is a higher level of consciousness to which we can arrive. And that's what we'll be exploring here. So in the 20th century, there were some key discoveries that were made by scientists, which shook loose this classical materialist model. Firstly, it was discovered that time, velocity, and position are all relative things. This was discovered by Einstein. There's no such thing as simultaneity, which means that time for me and time for you are actually different things. And that time depends on how fast I'm moving relative to you. And so everything is relative, in fact. And in fact, if you look at the world from the point of view of a beam of light, everything is frozen and standing still. Because light is relative to what we know the rest of the world and measure it. That's technical stuff. I'm not going to get into heavy general relativity theory here, but you probably are familiar with that idea. So that destroyed this notion that there is an absolute space and time, which is something that Newton thought. And that was a very twisted sort of notion. It was not easy to come up with this sort of idea. This was a very paradigm-shattering idea. But nevertheless, it was actually verified and proven, and we know that it's the case. We have actually built technologies like the GPS system, which depends on general relativity being true. It was also discovered that space is non-Euclidean. Einstein said that there isn't just space, there's a fabric, a four-dimensional fabric called space-time. Space and time are interwoven, and gravity affects the curvature of this non-Euclidean space. It was also discovered that particles or atoms are actually clouds of probabilities and not substantial objects. And it was discovered that when a particle is not being observed, that actually it exists as a superposition of all the possible states of where that particle could be. It's not merely that we don't know where the particle is because our instruments aren't accurate enough. It was literally discovered that there is no such thing as a particle. There are these probability fields, and we'll get into that a little bit more later. It was discovered that particles actually don't have a position or velocity. You would think they would if they were like ordinary objects, but particles are not ordinary objects. A particle is an abstract concept that we have invented to talk about certain phenomenon in the world and certain experimental results. But there actually is no particle there, and it has no position or velocity because it's actually in a state of superposition where it's all the possible states that it could be in simultaneously when you're not looking at it. That's pretty twisted stuff. It was also discovered, of course, by Einstein's famous equation that mass and energy are identical or convertible. E equals mc squared. Did you know that in a nuclear explosion, where does all that energy come from? What actually happens is you have a ball of plutonium or uranium which undergoes fusion or fission, and in that process of fusion or fission, what actually happens is that the initial mass of the uranium or plutonium gets decreased by a tiny fraction. Tiny fraction, like 0.000001 of a milligram, a very tiny fraction. And that tiny fraction of plutonium is literally converted into energy. The mass is converted into energy, and that turns out to be a huge amount of energy, enough to cause this nuclear mushroom cloud explosion, which obliterates everything within many miles. That shows you how much energy there is in a particle of mass. Enormous quantities of energy. So what this did is this blurred the distinction between mass and energy. And that was very interesting. It was also discovered that light is neither a particle nor a wave, but both, depending on observation. So this traditional Aristotelian idea that, well, an object must either be this way or that way. It's either A or it's B, but it can't be both. Right? Well, it was discovered that it can, and that it is, and that it must be. Because it depends on observation, you see. In the old Newtonian model, the classical model, it was assumed that the subject and the object are two separate and distinct things, such that the scientist who is looking at the particles or doing the lab experiment, he is sort of outside of the world, and he can look in objectively as an objective, impartial observer and just look and see, okay, so what is reality really like? And you can just kind of like look through a telescope and you can see, oh, well, that's how it is. But what quantum mechanics showed is that no, it doesn't work that way. You looking at the object affects the object. The subject and the object are entangled, and you can't extricate them from each other. The entanglement is absolutely necessary and fundamental. It was also discovered that observation affects all measurements, such that you can't actually take a measurement of anything without affecting the thing that you're measuring. Which should have been obvious from the very beginning, but the classical model sort of just assumed that the scientist isn't involved in the picture. Whereas in quantum mechanics, we realize that if we go deep enough, we have to say, no, I am involved in the picture. Because just the fact that I'm looking at an object already means that there's a photon that's kind of bouncing off the object going into my eye, and there's an complicated interaction there which entangles the subject and the object. It was also discovered that there's a phenomenon called quantum entanglement. And what that means is if you have two sister particles and you move them to opposite sides of the universe and you change the position or spin or rotation or momentum of one of the sister particles, its other sister particle will instantaneously react to the change that you made to this sister particle, even though they are 15 billion light years apart in distance. They will change instantly, violating, of course, Albert Einstein's idea that information can only propagate at the speed of light. So what quantum mechanics discovered is that actually nature violates the local realist view of causality. There is no such thing as a chain of causation that needs to happen. Reality can instantaneously know and react to changes in its own state. And this produces instant action at a distance. Einstein called it spooky action at a distance. It's quantum entanglement. So that kills the old idea of causality under the classical model. It was also discovered that 95% of the mass of our universe is not made out of matter or anything that we know or understand. 5% of the universe is classical matter, the stuff that we are made out of, the stuff you see all around you. The other 95% is broken into two things. 27% is dark matter, which is some other kind of matter that we don't really understand what it is or why it's there or what its properties are. And we can't really detect it other than through its gravitational effect. And we don't know what it's made out of. None of the particles that we presently understand, and we understand hundreds of subatomic particles, none of them are candidates for this dark matter as of yet. So that's still cutting edge research that's ongoing. And then the remaining 68% is dark energy. What the hell is dark energy? Well, we really don't know, but the best idea is that what dark energy is it's sort of just, it's actually a negative form of energy. It's the energy that exists in a pure vacuum of empty space, which is sort of the background energy which offsets the matter and the sort of positive energy, such that ultimately, and we don't know this for sure, but the speculation is now that actually the net energy of the universe appears to be zero, which would be an interesting result, such that the dark energy and the vacuum energy cancels out all the positive energy and all the matter, so that we can say that the whole thing came out of nothing as an infinite singularity back, stretching back to the Big Bang and even before that. So these are just some of the rather mind-blowing and twisted discoveries that were made in the 20th century. Now, let me give you a quick overview of quantum mechanics. This is quantum mechanics of the non-technical sort for the layman. So what quantum mechanics really says, it's not complicated. It says that there are no such thing as particles, really. So then what is there? Everything is fields. A particle is really just a field. It's a cloud of possibilities. When you look upon this cloud with some instrument or with your own eyes or with your own consciousness, what happens is that cloud congeals and collapses into a particular result. Now, these fields are very interesting things because what a field is, mathematically speaking, it's an infinite set of scalars. So that means that if you take every single point in space and you put a number on it, that will be a field. So if you have a two-dimensional space, like a piece of paper, imagine that every point on that paper can have a different value. Just a random value like 1, 5, 100, 200, and it's sort of distributed. So if you gave every point on that piece of paper, every atom on that piece of paper, and there's trillions of them there, a particular value, that would be a field. And there's different kinds of fields that science has discovered. So modern science, there's also a branch of quantum mechanics called quantum field theory, says that basically everything is a field. And so reality is an interaction of different fields coming together. Now, what's interesting about fields is that what is a field really? It's values. But values of what? What do they actually point to? And of course, the answer is nothing. There's nothing there. A field is infinite nothingness. Interesting coincidence. We'll get back to that. Modern physicists talk about and think about reality as something called quantum wave functions. So you can write an equation which represents a wave function for the probabilities of this cloud of possibilities of congealing down into one particular configuration that you see in the laboratory. And so there's different kinds of wave functions. And so really, when we're talking about what is everything made out of, what we're saying is that everything is wave functions. But what are these wave functions? What do they really point to? Another important component of superposition, of quantum mechanics, is superposition. Superposition is just, again, it says that when you're not looking at a thing, it exists as the state of all of its possibilities. So for example, imagine that if you're not looking at an elephant, you would think, well, if I'm not looking at an elephant, it's still an elephant, right? No, not really according to quantum mechanics. When you're not looking at an elephant, that elephant, just imagine, this is just a metaphor, that elephant exists as every other animal that it could have possibly been. Think about that. And really think through the radical consequences of this. It's enormous. When you're not looking at an elephant, that elephant is literally infinite. It's every possible elephant that could ever possibly be, that you could ever see, or any other creature could see, or any other instrument could detect. Not only that, but it also exists as a kangaroo, as a chipmunk, as a rhinoceros, as a beetle, as a bird, as a dinosaur, as everything else. And then when you look at it, it collapses down into that particular elephant that you see. That's a good metaphor for what superposition really means. But think about that and compare it to the classical model, because people, when they walk around the world, when you go to work, when you leave your children at school, for the day. Do you think that your children exist as children, as human beings? Do you think your house still exists? Do you think your office still exists? Your boss, your coworkers, your family members, when you're not looking at them? Of course you do. That's part of your materialist paradigm. And what we're saying is that that's not the case. That has been disproven. When you're not looking at your child, that child exists as infinity, as nothingness. When you're not looking at an elephant, it's infinity, it's nothingness. When you're not looking at your house, it's infinity, it's nothingness. That's what it is. That's also what you are, but you're not aware of it. So these wave functions, they collapse through observation. And so observation is essential and absolutely fundamental to the concept of reality. There is no concept of reality without observation, without participation, without subjectivity, without relativity. Relativity is reality. Without relativity, without a subjective point of view, what you have is you have everything. You have infinity. You have every single possibility. So you sitting here right there listening to me are experiencing a particular version of this infinity, the one from your point of view. Not only that, but you are that point of view. That's what you are. You're not a body. You're not a mind. You're not a thinking thing or a soul. You are the point of view. And you are, of course, also nothing and infinity. Because, this gets deep, but there is no difference actually between infinity and finity. Finity is implied by infinity. You actually cannot have infinity without also every possible finitude. That's good luck wrapping your mind around that one. That one requires enlightenment to understand. It's also important to point out, this is a confusion that many New Agers make, is that the observer can be any measuring device. The observer doesn't have to just be human consciousness. It could be a laser, a computer, an animal, a machine, a measuring stick, whatever. It doesn't have to be literally human consciousness or the human mind. Of course, there's an additional wrinkle, though, to that, because even though a good scientist, a good quantum theorist will be sure to stress this point, and he will actually use this point to say, aha, Leo, but that means that if we can just use a laser to be the observer, then in what sense is consciousness important or essential to quantum mechanics? But of course it still is. Absolutely it still is, because the only consciousness that exists is one consciousness, your consciousness. There is no other consciousness but your consciousness. That laser device, that computer, that measuring stick, and even that animal or whatever who is doing this measuring and collapsing the wave function, guess what? It's your consciousness. It's nothing separate from you. So in the end, it all boils down to your consciousness, because all of reality is occurring within your consciousness, which really should be obvious, but, many good scientists miss this nonetheless. So that's quantum mechanics in a nutshell. It's important to understand that quantum mechanics is not just philosophy or theory, but that it's extremely accurate. It actually predicts with extreme accuracy real physical phenomena that we use every day. And many of our technologies are completely and utterly dependent upon quantum mechanics being true and being accurate. Most modern telecommunications and computer technologies and smartphones and video games and all this stuff that would not be possible if these discoveries in quantum mechanics were not made in the 1920s. And in fact, it's said that quantum mechanics is the most accurate scientific theory that has ever been proposed. It's been the most validated of theories. And while all that's true, there is a trick here, or a trap, because the human mind, because it's so pragmatically oriented, it very easily gives up questions about the truth and the meaning of things as soon as it discovers something that just works. And so many, even good scientists these days, what they did is they said, oh, well, it just works. It works. It's accurate. Look, so who cares what it really means? Who cares what the implications are? It just works. Let's just go start using it to build computers and phones and video games and all this sort of stuff. And what does it really mean? The interpretations, that's for philosophers. That's for armchair debates. That's speculative stuff. We leave that to the theologians, and who cares? Let's just go build our technology. We got the real goods. But actually, when you take that attitude, you miss something very important. And what you miss is you miss the very substance of the thing you were studying. What does quantum mechanics really say about reality? What does it say is the substance of everything? Let's think it through. Quantum mechanics tells us that matter is identical to particles, which is identical to wave functions, which is identical to energy, which is identical to fields. But what is matter? What are particles? What are wave functions? What is energy? What are fields? What are strings? What are functions and equations? What is mathematics? And what is science? And what is human thought? Because all of this, notice, is human thought. And what is consciousness? Because all of this is taking place within consciousness. You never encounter a particle or a wave function or an equation or a string or a field. You only encounter your own consciousness. So you see the circularity here? You see the strange loopiness of what we're doing here? We're talking about the external world as though it's out there, but really we're talking about our own minds. And then when we wonder, well, where does my mind exist? Well, of course, it exists in the external world. It exists in the physical body, which is sitting in the external world. It exists in the brain. But then where is the brain? How do I know there's a brain? Because it's in my mind. So then is the mind in the brain, or is the brain in the mind? Or maybe it's both. Or maybe it's neither. Or maybe it's a superposition of all of those. Interesting. That's what I mean by paradox. That's what I mean by strange loop. This is not a mistake. This does not mean that we don't know. This means we know, but the thing we know is so radical that your mind can't handle it. That's a very big difference, a very important distinction that gets lost on even many scientists. And then we have the ultimate question, which science still hasn't answered. Why does reality exist? Why is there something rather than nothing? Very good question. But see, the typical scientist will say, oh, Leo, that's a kind of question, that's a philosophical, that's a religious question. You can't really answer that question. Science can't possibly answer that question. Or can it? Or maybe the version of science that you're using can't answer that question, but a different version of science can. Maybe it's not that the question can't be answered, maybe that the question has been answered, but that you are not prepared to understand the answer. Maybe the answer cannot come to you in the form of a verbal explanation, but rather you must embody the answer because, after all, you are involved in the inquiry, deeply involved. And so this classical assumption that, well, I'm over here and reality is over there, so I can just ask the question, well, how come reality exists over there while I'm sitting over here? You can't do that. Quantum mechanics says we're entangled. The questioner is involved with the question at the most fundamental level. So when you ask the question, why does reality exist? You ask the question, why do I exist? And what am I? And what is reality? And yes, absolutely, there is an answer to that question, and absolutely you can know it. But it's going to require a sacrifice. It's going to require a sacrifice of the self. You will have to surrender everything you know and everything you hold dear to embody the answer. Because as it turns out, you are infinite, and for you to realize this infinity and to realize that infinity must exist because it is every possibility, is to literally face your own death. Because right now you are conscious as a finite observer looking at the world from a perspective. And what we're asking you to do is to collapse your perspective, or rather to take the reverse of the process. So you have a wave function, you look at it, at an object, that collapses the wave function into a particular thing, where before it was just a cloud of possibilities. And now what we're asking you to do is to run that process in the reverse, which very few people do, because it's not easy. We're asking you to go from being this particle, this particular specific thing, to dissolve, uncollapse the wave function, and become the cloud of infinite possibility. And of course, you know what that means. That is otherwise known as physical death. We're asking you to physically die, which of course nobody wants to do, which of course is why this stuff stays relatively unknown. A very important question that needs to be asked additionally to all this is, what is quantum mechanics itself? Because see, we use quantum mechanics to describe reality, but then quantum mechanics, is it sitting outside of reality or is it part of reality? It's a part of reality. So then if we're using quantum mechanics to describe reality, what the hell is quantum mechanics? What are we really explaining? This is a question that very few serious physicists really ask, because this gets us deep into the weeds with epistemology, and this gets us face to face with the paradox and the strange loopiness of this entire investigation. But I'll spoil it for you. What is quantum mechanics? It's a mathematical model. It's a thought. It's a thought within consciousness. It's important not to confuse quantum mechanics with the thing that it is describing. Quantum mechanics is a map, and as we know, the map is not the territory. The menu is not the meal. Quantum mechanics is the menu, not the meal. And this is a big mistake that many modern materialist scientists make, including those that work within quantum mechanics, which is rather shameful and it's rather embarrassing, but they make it. And I'll point this out to you in a moment, how this really works. Now, quantum mechanics has many different interpretations, and there has been debate throughout the last 100 years as to what quantum mechanics really means. And there's different schools and camps. Scientists break and kind of fight with each other into different camps about this. Some are anti-realists, some are realists, some are many world interpretation subscribers, and some think of it as formalism and this and that. So there's different schools. And I've looked into all those. And what I'm going to be presenting to you here is not one particular interpretation, but something transcendent, something that goes beyond all these interpretations. All these interpretations, including all the interpretations that came from the granddaddies of quantum mechanics, they are all partial, and they all lack the ultimate understanding, because the ultimate understanding must come through actual embodiment and not just thinking. And an interpretation is, after all, just a thought process. So we're going to be presenting some multiple interpretations to you here. I'm going to be reading a lot of quotes to you now. So I've explained to you what quantum mechanics basically is in a nutshell, how it all works. We've set it all up. And now what I want to do is I want to really drive the point home into your mind, how serious these implications are. And the way we're going to do that is I'm going to be citing to you from various professors and academics and the granddaddies of quantum mechanics, a lot of quotes from them, which are going to blow your mind. And I'm going to be offering a lot of commentary to get you to see the stuff they understood, and then also going beyond all that to the stuff that is transcendent, to the stuff that I really want you to get to the stuff that quantum mechanics is pointing at, which it can't get to through its own symbolic methods. And now I want to introduce you to the first physicist who I'll be quoting extensively, and he is a modern physicist. So I selected him in particular because he's a great representative example of a high-quality modern academic who is very deeply subscribed to the materialist paradigm without realizing that he is. And his name is Sean Carroll. He's a research professor at Caltech. He specializes in cosmology, dark energy, and general relativity. He has written books. He has given lectures about quantum mechanics. In fact, I highly recommend his lectures. If you want to understand the nuts and bolts of quantum mechanics in a not overly technical way, but still in a much more technical way than I'm covering here, some of the mathematics and some of the various experiments and things like that, then he's a very reliable and high-quality source. I'm going to be quoting from his book called The Big Picture, where he talks a lot about this stuff. I'll be quoting a lot, but I'll also be interjecting with my own commentary here. Because, again, I'm not just interested in saying what other people have said, but taking you to the next level. So, I actually really enjoy Sean Carroll. I think he has a good sense of humor. I think he's a very smart guy. I just think that the only problem is that he is not taking it to the highest level that you can take it. So let's get some quotes going here. He says, quote, "In quantum mechanics, the state of a system is a superposition of all the possible measurement outcomes, known as the wave function of a system. The wave function is a combination of every result that you could get by doing an observation, with different weights for each possibility. In principle, every possible measurement outcome can be part of the quantum state." End quote. So here he's just setting up the basic theory of quantum mechanics and how it works. We already talked about this. So the one additional wrinkle he's adding here is that there are different weights to these possibilities. So of course, it's not equally likely that everything will precipitate out of this field of infinite possibility. Particular things tend to precipitate out at various degrees of possibility. So that's why the equation has a bunch of variables in it and stuff, because you're trying to account for those differences in possibilities. And then it's that which you're actually using to then make predictions about the world, because some things become very probable and other things become extremely unlikely from those equations. And then how are those equations created? Well, of course, from doing experiments. And by doing all these experiments many, many times, thousands of times over, you find out what the probabilities are. Now, it's very important to understand, though, and this is still my commentary, that it's not that we don't have good enough tools to measure what's really going on inside, and therefore we're just using statistical analysis. That's not what quantum mechanics is saying. Quantum mechanics is literally saying that there's nothing there when you're not looking at it. Let's continue with what he writes. Quote, "A radical approach is to simply deny the existence of an underlying reality altogether." That's what I'm telling you. This would be an anti-realist approach to quantum mechanics, since it treats the theory as merely a bookkeeping device for predicting the outcomes of future experiments. If you ask an anti-realist what aspect of the current universe our knowledge is about, they will tell you that that's not a sensible question to ask. There is, in this view, no underlying stuff that is being described by quantum mechanics. All we are ever allowed to talk about is the outcomes of experimental measurements. So again, this is my commentary now. That's right. So what he's basically saying is he's saying that the interpretation that Leo is offering you is an anti-realist interpretation of quantum mechanics. And that's correct. I am arguing against realism, and I am arguing against materialism. Of course, he's a materialist and he's a realist, so he's not going to accept this position. But we'll get to that in a minute. Next he says, quote, anti-realism is a pretty dramatic step to take. It seems to have been advocated by no less of an authority than Niels Bohr, the grandfather of quantum mechanics. His views, Bohr's views, were described as, and he quotes Bohr. Now this is Bohr talking. There is no quantum world. There is only the abstract physical description. It is wrong to think that the task of physics is to find out how nature is. Physics concerns what we can say about nature. End quote. So Niels Bohr was an anti-realist. But Sean Carroll continues, quote, perhaps the biggest problem with anti-realism is that it's hard to see how it could be in a position to hold, how it could be a position that one can hold with perfect consistency. It's one thing to say that our understanding of nature is incomplete. It's another thing entirely to say that there is no such thing as nature. For one thing, who is it that is doing the saying? Even Bohr, in the quote above, speaks of what we can say about nature, and that would seem to imply that there's something called nature about which we can say these things. End quote. So here we need some commentary. So here's where he's already going off the rails. Here's the problem, is that he's sort of positing this little paradox within Bohr's speaking, and he's citing that as an example of the fact that, well, that means anti-realism really can't be true, or it's too radical of a leap to take. That's right, though. It is a radical leap to take because that's what quantum mechanics is. It's extremely radical when you really understand it. So the problem here isn't really one of there not being enough evidence for the radicalness, rather that it's you don't want to accept the radicalness. Because what you're looking for is you're looking for perfect consistency in being able to symbolize reality, which of course is impossible because reality is a strange loop. So what Sean Carroll is pointing out correctly here is that the way that Bohr is speaking ultimately leads to a strange loop. Yes, of course. That's not a bug, that's a feature. That's precisely what's necessary. Now, Bohr, who I will be quoting extensively a little bit later in this episode, understood this. He was a more profound metaphysical and epistemological thinker because he was a visionary scientist. He went way beyond the traditional paradigms that they teach you in universities. He knew how to think outside the box, and that's precisely what's necessary when we're talking about the fundamental nature of reality. Now, Sean Carroll, very interestingly, he also says, for one thing, who is it that's doing the saying? Precisely. Who is it that's doing the quantum mechanics? Who is it that's being conscious of reality? Who is it that's doing the lab experiments? Precisely. What is that thing? That's the ultimate question we're trying to get at. What is that thing? And that's something that he's not conscious of yet. Because if he was, he wouldn't be taking this materialist position, because it would be utterly untenable. So yes, what anti-realism is saying is that there is no such thing as reality. There is no such thing as nature. And what quantum mechanics is it's a set of symbols or bookkeeping devices. That's exactly what it is. That's exactly what mathematics is. That's exactly how science works. There's not a problem with that. That is what it is. Now, Sean Carroll goes on and he says, quote, fortunately, we have not yet exhausted all our possibilities. So now he's going to present a new possibility to anti-realism. This is a different interpretation of quantum mechanics. So he says, quote, the simplest possibility is that the quantum wave function isn't a bookkeeping device at all, nor is it one of many kinds of quantum variables. The wave function simply represents reality directly. The modern quantum theorist can think of the world as a wave function, full stop. Now, this is patently absurd. This is a huge mistake. So let's just take this sentence that the wave function simply represents reality directly. So what this is showing is a lack of consciousness of what a wave function is. A wave function is a set of symbols. To say that a set of symbols represents reality directly is an oxymoron. It's patently absurd because a symbol only works through representation. That's what a symbol does. So you can't represent reality directly because representation by definition is indirect. Every representation isn't the thing that's being represented. You see, like if I took a photograph of you, that would be a representation of you. And then if I showed that to you and I said, look, this is directly you. No, it's not. That's a photograph of me, or a photograph of you. In that case, you would say. You see? But what Sean Carroll is doing here, because he doesn't like anti-realism, he's not open-minded to that possibility. So he wants to maintain materialism. So can you do that? Yes, in theory you can. How do you do that? By being blind to what representation is, to what symbolism is, and to mistake the mathematics, the bookkeeping device for reality. So see, what Sean Carroll wants to do here is he wants to make the bookkeeping device, make his equations actual reality. Now, of course, equations are a part of reality, but they are not the reality they are representing. In the same way that a menu at a restaurant, it is real, it is a part of reality, but the menu is not the cheeseburger that's depicted on the menu, you see. To say that what is ultimately real is the menu and not the cheeseburger is absurd. And that's exactly what's happening here. But let me quote him some more. He says, quote, "But if everything is just a wave function, what makes the wave function collapse? And why is the act of observation so important?" Aha, indeed. That's real tricky for materialists. So he says, quote, a resolution was suggested in the 1950s by a young physicist named Hugh Everett III. He proposed that there was only one piece of quantum ontology, the wave function, and only one way that it ever evolves, via the Schrödinger equation. This means there is no collapse, there is no fundamental division between system and observer, and no special role for observation at all. Of course, that's what a materialist must do. But if that's right, he continues, why does it seem to us that the wave function collapses when we observe them? In classical mechanics, we can think of every different place or piece of the world as having its own state. For example, the Earth moving around the Sun with a particular position velocity, and Mars has a position velocity of its own. Now, quantum mechanics tells a different story. There is not a wave function for the Earth and another one for Mars, and so on throughout all of space. There is only one wave function for the entire universe at once. And we call it, with no hint of modesty, the wave function of the universe. A wave function is simply a number that we assign to every measurement outcome. So the wave function of the universe assigns a number to every possible way that objects in the universe could be distributed through space. There's one number for the Earth is here and Mars is over there, and then another number for the Earth is here and Mars is somewhere else, and another number for the Earth is at this place and Mars is yet at some other place. Everett says that we should take the formalism of quantum mechanics at face value. Not only is the system you're going to observe described by a wave function, but you yourself are described by a wave function. That means that you can be in a superposition. When you make a measurement of a particle to see whether it's spinning clockwise or counterclockwise, Everett suggests, the wave function doesn't collapse into one possibility or the other. It evolves smoothly into an entangled superposition, part of which has the particle is spinning clockwise, and you saw it spinning clockwise, and the other part has that the particle is spinning counterclockwise, and you saw it spinning counterclockwise. Both parts of the superposition actually exist, and they continue to exist and evolve as the Schrödinger equation demands. So let's pause right there and add some commentary. So you see what he's saying? He's saying that this is basically a multiple universe, multiple world interpretation of quantum mechanics, and that's what it's called. Is he saying that basically every possibility that can exist does exist, and they all just are sort of superimposed into each other and then are just sort of like acting themselves out without there even being an observer. There is sort of like just being. Now, what do I have to say about this? Yes, in a sense, actually, this is exactly correct. In a sense, Sean Carroll is perfectly correct. There actually are no observers, but not in the way he thinks. What's happening here right now as I'm standing before you is that there is no observation going on. There is purely being. And in fact, this particular collapse of the wave function, this particular finite moment that I'm experiencing or that you're experiencing of me, is actually one infinitesimal piece of absolute infinity. Absolute infinity is every single possibility that could ever possibly be. So this is what Sean Carroll is calling the wave function of the universe. Except it's not a set of symbols. It's not an equation. This is it. You're in it. You are it. And yes, it is in this state of superposition. And yes, there's no observation going on because there is no observer. That's what enlightenment tells you. That's what non-duality tells you. Everything is one. All distinctions collapse, and therefore there can be no distinction between observer and observed. The thing you're observing is you, which means that it's being. At that point, it's no longer observation. So when you become deeply, deeply conscious to the level of enlightenment, conscious to the level of absolute infinity, what you become conscious of is that there was never an observer to begin with, and that what's happening here is not a process of perception, but it's a process of pure being. And that might sound like a word game, but let me assure you it's anything but. This is a very radical, very deep, absolute state of consciousness. It's utterly mind-blowing. It completely destroys your understanding of what reality is. But at the same time, you realize there is no such thing as reality, because part of the superposition is that nothing exists. You see, to have a true superposition of every single possibility, you must include the possibility of every particle being in every place. We got that part. But the part that these quantum physicists like Sean Carroll, because they're materialists, are missing is you're missing the fact that at the same time, it also includes a superposition that negates every single one of those. So while the ultimate wave function of the universe includes a particle everywhere, it also includes a particle nowhere. So that's why I say that right now I'm standing here before you, but everything that's being experienced here is nothing. It's empty. There's nothing here. Nothing isn't an empty space or a blank void or a black hole. Nothing is precisely everything you've ever experienced in your life. That's a one piece of nothing. That's the key mistake that every physicist and every materialist makes. And I made this mistake for a long time as well, because this only becomes clear when you awaken. Now he goes on to say, quote, "At last, then, we have a candidate for the final answer to the critical ontological question, what is the world really? It is a quantum wave function, at least until a better theory comes along." End quote. Now here is the conclusion where he is wrong. So what is the world really? It's not a quantum wave function. The world really is absolute infinity. It is everything and nothing. It is a superposition of every single possibility, including the negation of every possibility. It's the ultimate strange loop, the ultimate paradox, the ultimate mindfuck. Your mind cannot understand this because you are it. You can't understand it because it's already you. You need to become it, rather than trying to understand it through an indirect method, through symbols. So the mistake he's done here ultimately is he has concluded that his symbols and equations are the world, which is patently absurd. He's confused the menu for the meal. Because he's a theoretician, because he's committed to understanding the world rationally. And as far as rationality and theories go, he's right. This is the best you can do with theory. But reality is not a theory. And the assumption that you can't go and become reality directly, that you can't transcend your theories, that is an incorrect assumption. And let's wrap up here with a few more quotes from him. He says, quote, "While we do not have a finished understanding of quantum mechanics at a fundamental level, there is nothing we know about it that necessarily invalidates determinism, realism, the idea that there is an objective real world, or physicalism, the world is purely physical. All of these features of the Newtonian, Laplacian clockwork universe can easily still hold true in quantum mechanics, but we don't know for sure." End quote. So he's carrying on the mistake. It's actually not the case that quantum mechanics is still open to realism and physicalism. Quantum mechanics has actually disproven and debunked these. But because he starts with the assumption that realism and physicalism must be true, he carries it in. So his assumption becomes his conclusion. Now, at this point, you might still be wondering, well, Leo, why should I believe your interpretation over Sean Carroll's interpretation? Because he's a physicist, he works at Caltech, he wrote this book, and, isn't he a more reliable source? Well, I'm not going to ask you just to believe me. I am going to quote to you extensively from the actual founders of quantum mechanics who came before Sean Carroll, and they will explain to you that actually quantum mechanics completely debunks realism and physicalism. And this idea of a Newtonian, Laplacian clockwork universe, this is gone. This is gone. The only way it survives is as part of your metaphysical dogma, as unseen assumptions about the world, which you picked up as part of your culture or as part of your institution or part of the culture of academia, which you never questioned. And for Sean Carroll, you can't blame him too much because he's a physicist and he does technical work. So for him, it's not important to really have a direct experience of the nature of existence. That's sort of beyond the domain of what the university has carved out for him. His job is to teach, to write books, to be a professor, to do research, make papers, make technical discoveries. None of that has anything to do with what we're really talking about here. Although what we're talking about here is extremely important and it's being pointed to by his work. And finally, he says, quote, "In a sense, it is the ultimate unification. Not only does the deepest layer of reality not consist of things and mountains, it doesn't consist of things like electrons and photons. It's just the quantum wave function, and everything else is a convenient way of talking." End quote. So again, he's part right and part wrong. He's right that this is the ultimate unification. We're unifying everything into one quantum wave function, which is a superposition of every single possibility, otherwise known as absolute infinity. You don't even need to write an equation for it. Just write an infinity symbol. That is the shortest symbolization of what all of reality is. You don't need technical quantum mechanical equations to do that. Of course, the complaint will be, well, Leo, if I just write an infinity symbol, what can I do with it? It's not very practical. I can't go build a supercomputer, or I can't build a smartphone. I can't make some new, rocket ship technology using your infinity symbol. I need something more concrete, something a little bit smaller, more fine-grained. Yes, precisely. Do you see that the endeavor of science to be practical and to make discoveries that can enable the creation of technology and the prediction of certain specific situations in the future, that is, in a sense, antithetical to what we're really asking about when we're asking about what is the nature of everything. These two questions are almost completely at odds. Because when we're asking about what is the question of everything, we're asking about the biggest possible picture. We shouldn't have an expectation that the answer to that will be practical, that we can just take it and immediately apply it to build a rocket ship. Otherwise, we don't want it. No, the nature of everything, in a sense, you might say, well, what's so practical about knowing the nature of everything? Well, in a sense, it's not practical. But in another sense, it's the ultimate practicality, because the nature of everything is what's responsible for there being anything at all, which is what we're interested in, the ultimate question. Why is there anything at all? If there was an absolute infinity, you wouldn't have anything else. You wouldn't have science. You wouldn't have math. You wouldn't have physics professors. You wouldn't have Caltech. You wouldn't have MIT. You wouldn't have me. You wouldn't have you. There'd be nothing. Well, not really, but that's not possible, because see, nothing includes everything. That's the paradox of it. Nothing is unstable. You might think, well, why isn't there just like a black hole or just a blank space? Why is there stuff? Because think it through. If you just have a blank space, the question then comes up, well, why would there be a blank space? What would enforce there being a blank space and not being, for example, an elephant? So then you're forced to say, okay, well, there must be an elephant then too. So now we have a blank space and an elephant. Okay, well, what prevents a kangaroo? Okay, fine, we'll add a kangaroo. Okay, so what prevents a car? Okay, fine, we'll add a car. So what prevents humans? Okay, fine, we'll add humans. So what prevents bacteria? Okay, fine, we'll add bacteria. What prevents aliens? Okay, fine, we'll add aliens. What prevents unicorns? Nothing, we'll add a unicorn. We'll add every fucking thing. You see, because nothing is unstable if it stays as a blank. Nothing must instantly inflate. See, this doesn't happen through time. This inflation happens instantly. If you imagine that the universe at the very, very beginning was just a blank slate, you've already imagined every possibility, because that blank slate instantly must inflate to include everything else, because there's nothing to enforce the emptiness. And yet at the same time, the emptiness doesn't disappear. The emptiness permeates through all the elephants and all the kangaroos and all the people and all the cars and everything else. And the emptiness is not separate from the elephant. The elephant is emptiness. The elephant is what emptiness is. But this gets lost on physicists. So in this quote, Sean Carroll says that everything is just a quantum wave function. In a sense, that's true, but in another sense, that's false. He says that everything else is just a convenient way of talking. So when we're talking about oceans and mountains and elephants and photons and electrons and protons and all this sorts of stuff, these are just convenient labels. And really, it's the equations which are the real deal. No, the equations are also convenient labels. The real deal is the real deal. There is nothing more real than infinity. It's the only reality there can be. There can't be anything outside of it because it already includes every possibility that could be outside of it or inside of it. So there you have it. I've broken down how modern quantum physicists think of this stuff, and now we need to move on to the granddaddies of quantum mechanics and see what they have to say.